Amplify Science, Matter and Energy in Ecosystems, Chapter 3, Lesson 3.2, Total Carbon in an Ecosystem, Lesson Review video. So in Step 1, you're given the warm-up, and whether or not you agree with Gabriella's statement is up to you at this point, and explain your answer, so I can't really tell you right or wrong what an answer might be, so that's going to be up to you at this point. Now in Step 2, I want to point out that as you read this article, it says paragraphs 4 and 5. So I'm going to scroll down to paragraphs 4 and 5 and making sure you're picking the right paragraphs. And that is this thing called the carbon cycle. And as you read about the carbon cycle, the first thing we want you to notice, it's a closed system. That means nothing goes in and nothing comes out. So the total amount of carbon in the system stays the same. Okay? It's rare for anything to get off or on this planet. Very small amounts of things in terms of, meteorite sort of stuff. But other than that, things are staying put. But things do cycle from abiotic to biotic. In other words, carbon dioxide in the environment and then turned into energy storage molecules in an ecosystem, passed from producers to consumers to decomposers, and then released back out into the air again. And those terms, photosynthesis and cellular respiration, just explain that. We've gone over those numerous times, how carbon dioxide and water become glucose and oxygen, and how glucose and oxygen become carbon dioxide and water. You'll notice the image or the graphic looks just like your simulation. So they're just making it a point that in your simulation, you're paying attention to the same carbon cycle going round and round. Okay? And then they introduce this idea of fossil fuels. The main point of the article is if you go get carbon trapped deep within the earth and you release it by using it as fuel, burning it, massive amounts of carbon dioxide end up in the atmosphere or in the abiotic part, and it can tip the carbon cycle from its normal cycle of evenly going back and forth to releasing more than it takes back in, and that obviously can impact the planet, and that's what you read about already, so we don't need to go into that. In Step 3, you're playing the carbon game. Now, your game cards are in class. You could always print them off if you needed to play it at home and then grab some sort of tokens. But the instructions are there. The part we need to review, making sure you understood this, is at the beginning of the game, you are given 30 tokens. So the total amount of carbon in the ecosystem is 30. How many are in biotic and how many are in abiotic? That depends on you and the game and how you have it set up. But it really doesn't matter. Okay? As you go through and answer these questions, depending on the card sequence you choose and what happens in your game, the carbon will move around, but the total amount of carbon in the ecosystem is always 30. That's the point of the game. You always come back to 30. Started with 30, ended with 30, it's always 30. It may move from biotic to abiotic. You may have 8 and 22, and then it becomes 15 and 15, and then it moves on to 20 and 10. It doesn't matter. The total amount of carbon stays at 30. That's what they want you to understand. It's a closed system. Tokens don't get added to the game, and they don't leave the game. In the homework portion, you're going to think of another topic that reminds you of this and how it's related. Okay, and again, that's kind of up to you and what interests you. So that is 3.2. It doesn't take long. The game is about a 5-minute game, so this should allow you to revisit your answers and also keep up fairly easily. If you have any questions, be sure you ask in class or send me a message.